Okay, we are Team 15. I'm Drew Harris.
I'm Farah Burhan.
I'm Hazi Rahman.
And we're here today to discuss the first design phase of our team's solution to the BRG, which we've called the Arduino board. So just a brief introduction. First of all, what is a BRG? BRG is short for Battlefrog Rube Goldberg, and it is a physical demonstration of some educational concept in the years K through 12. The BRG is confined to three essential components. It must use an Arduino. Specifically, it must use an Arduino to add energy to the system, must be built on a 16-inch by 16-inch pegboard, and it must accept a ping pong ball at a certain speed and release that same ping pong ball at the exact same speed on the other side of the machine. So what we're going to discuss today is our first design phase, which comprises of essentially four key components. We have project planning and management, we have customer needs, which we have assessed customer needs, and from those customer needs, we have developed some product specifications. And based on those three things I've just said, and the information we've gathered thus far, we're going to perform a projective economic analysis just to look at the economics of this project and where we see it going.
So for BRG project, we've decided to demonstrate a concept for mathematics primary school level. We have generated three proposals, which each proposal demonstrating different concept. Proposal C is the only proposal that demonstrates two concepts rather than one. This is good because it creates a larger group of potential customers, which will generate more sales. And all of the three proposals is a derivative of existing product platform. This is because there are already existing products in the market. Okay, so next. Okay, this figure demonstrates the technological trajectories for all three proposals. As you can see over here, proposal A is used the most advanced technology. This is shown because it starts a bit later than the other ones, and it needs a lot more time to fully develop. And for proposal B and C, they use the same technology, but proposal C is slower to develop because it demonstrates multiple functions. Based on this, we decided to prioritize proposal B as it matures faster. And based on that too, we've decided to use a customer-focused competitive products because the proposal B appeals more to customer.
Okay, so in order to summarize the planning and management component of this design phase one, our team developed a mission statement. You'll see at the top of our mission statement there we have the name of our product, which is the Arduino board, and just to hit a few key points of the mission statement, we have our product description, which is that the Arduino board is a physical learning tool driven by Arduino and designed to demonstrate the concept of addition. In addition to that, we have our primary market, which we've established as primary education teaching professionals, and this could also be extended to primary school level administrators if they were looking to buy this type of thing for their whole department. Our secondary market would be parents of primary school age children, and specifically homeschooling parents, because they'd be more interested in this kind of thing, but not limited to just them. You'll also see there we have assumptions, stakeholders, and benefit proposition, key business goals. These are all important things, but for the purpose of brevity, I'd just like to touch on those three things there.
So next is the use case scenario. As you can see, on the left-hand side is a use case scenario, and on the right-hand side is a summary of the use case in a flowchart. So as we can see over here, in the demonstration section, it is heavily driven by Arduino program. Thus, when designing our project, we must take account into the difficulty of the Arduino coding. Next is the Gantt chart. We've summarized our project progression. As of March 20th, we have completed 4 tasks already. And as you can see over here, prototyping is given the most time, the length of time. This is because this is where the team will anticipate most of the problems will be. Thus, if you want to shorten the length of the project, or if we have problems in other sites, in other parts of the task, we can shorten the prototyping task.
The next part is the customer needs. We interviewed 6 different customers ranging from education professionals to parents. Okay, this is the customer statement raw data. We will given the interpreted need, and then we will categorize into primary or the secondary needs. Okay, the first one is I would like the student to participate in the demonstration. This is interpreted as the BRG should involve students while the program is running. We categorize it as the primary needs because we need the students to interact with our product while the program is running. The number 5 is I like the overall look of the model as it attracts students to participate. We interpreted it as the model should be aesthetically pleasing. We categorize this as the secondary need because we want to focus on the functionality rather than the aesthetic part. And the last one is the kit must be safe for my children. The interpreted need for this one is that the kit must include safety precaution. We categorize it as primary need because our product consists of small parts and some electronic parts, so we need it to be safe for our users. The next is the product specifications. This QFD table summarizes the customer needs and the specifications of our product. The first customer need is the kit need to be safe, and we give it the highest importance rank because we need our product to be safe for the user. And the kit need to be portable to receive the lowest rank because we want to focus on its functionality first. Okay. The next is the specification. We include number of small parts as our specification because we designed this project for the first and second grade students. So we need it to be safe for them to use and be able to interact with it. The next one is the simple program user interface. We want the user with minimal knowledge of Arduino to be able to use this product and follow through the process. Okay, there are correlation between the specification and customer needs. For the kit needs to be safe, it correlates with the number of small parts, the storage, and the reusable for many years. The next part is the technical importance, difficulty, and priority. For the technical importance part, the number of small parts received the highest score, and it is because the team believes that the small number of parts can ensure the safety of our product. For the overall cost, it is ranked number 5 because we believe that we want to focus on its functionality rather than its overall cost. Okay. For the technical difficulty, 5 being the most trivial task to be achieved and 1 being the most difficult task to be achieved. For the number of small parts, it received the most easiest task to be achieved because the team believed that we can easily minimize the number of parts in our project. And the overall cost received the lowest number of technical difficulty because we need to experiment different type of material to ensure the low cost of our project. Okay. For the technical priority, we believe that we need to prioritize the number of small parts rather than the other specifications to further with our design process.
Okay, so taking into consideration everything that our team has talked about thus far, we were able to perform an economic analysis. Now, obviously, at this point, being only in design phase 1, any economic analysis is going to be purely projective. But nonetheless, it does still serve as a useful tool for evaluating the economic viability of our project. Now, a few key points from this graph I'd like to point out. We have our break-even, which occurs at a quantity of 200 units. We have maximum profit around $15,000, and that occurs at a quantity of 500 units. And that is just based on, we've limited our analysis to that quantity based on the production capabilities of VTEPs. And the reason we had to limit our analysis in the first place is because we chose a fixed price scenario in which our price is set at $75 and we have a variable cost of $25 per unit. The fixed cost you'll see is around $10,000, and that's just something given to us by VTEPs, something we can't change. So in summary, like we said in the very beginning, 4 key components to this design phase 1. We have project planning and management. We've assessed customer needs, and based on those customer needs, we've established product specifications. Taking into consideration all of that, we were able to perform a preliminary economic analysis to give an idea of the economic viability of this project. Now, hopefully we were able to communicate those ideas to you fairly effectively, and looking forward where the team is headed, we have product decomposition, model selection, further economic analysis. That's something that's going to be there throughout the remainder of this project. We have legal considerations, looking at other products that are out there now, how similar they are to ours, and a fair modes and effect analysis to perform.